substitution reactions of benzene are actually done in 3 steps. Their mechanism consists on 3 steps. First step is the formation of electrophile, and second step is the attack of benzene pi electron on that electrophile, and the third step is the reformation of benzene ring. We can remember this general mechanism to do other 5 its reactions, substitution reactions. If you have any question regarding substitution reactions, you can ask in comment. Thank you. Assalamu students. In this video lecture, I am going to discuss electrophilic substitution reactions of benzene. We know that benzene is the most stable molecule and it shows substitution reactions and addition reactions. It do not show elimination reaction. In this video lecture, our major focus will be on electrophilic substitution reactions of benzene. First of all, I am going to explain general mechanism of electrophilic substitution reaction mechanism. Here is the general reaction. General reaction. In this case, one hydrogen of benzene is replaced with any electrophile, and that electrophile is now I am representing it as a E plus. It forms substituted benzene, monosubstituted benzene. How this substitution is occurred? It has mechanism, and this mechanism follows 3 steps. First step is generation of electrophile. Generation of electrophile. What happens in first step? In this step, electrophile is formed, and this reaction is occurred in between reagent and catalyst. For example, we have reagent X2 and it is going to react with catalyst, that's FeX3. FeX3 will draw one X atom with its electron toward itself and forms FeX4 negative and one X positive. Now X positive has tendency to attract electron pair of benzene ring, pi electron pair of benzene ring. So second step is attack of pi electron of benzene ring. In this step, pi electron of benzene ring attacks to that electrophile that is shown by X positive. These 2 electrons will attack on this X positive and forms this structure having X atom. This carbon has deficiency of electrons, so we have to write positive charge on this carbon atom. And third step is the removal of hydrogen atom to form benzene ring. At the end, benzene ring is regenerated. In this case, one hydrogen atom is lost it is benzene ring. Here is positive charge and hydrogen from this carbon atom will be lost. We can see that here is formed FeX4 negative. So it gives X negative anion, and this X negative will pick this hydrogen atom and forms benzene ring again. HX will be removed, and here is the substituted benzene ring. Substituted benzene ring. The substitution of benzene ring occurred through three different steps. First step is the generation of electrophile. In this case, electrophile is generated, and we know that electrophile is a species that has the ability to attract electron pair, and it has tendency to attract electron pair. In second step, pi electron of benzene ring attach to that electrophile and forms a bond in between electrophile and the ring of benzene. As we know that this bond is now formed in between carbon and that electrophile, so this carbon has deficiency of electrons. So in next step, there is the reformation of benzene ring or regaining of aromatic character, and the negative anion that was formed in first step will pick the hydrogen atom, and these electrons will come over into benzene ring and forms again benzene ring. These three steps are followed by all substitution reactions of benzene. A few substitution reactions of benzene are: first is halogenation. Second is alkylation. Federal-Croft alkylation. Third is Federal-Croft acylation. Fourth is sulfonation. And the last one is nitration. All these reactions follows this mechanism. Now going toward the first reaction, that's halogenation. In this case, one hydrogen of benzene is replaced with the halogen atom, so we can write it as it is the introduction of X atom in benzene, and we can use the catalyst FeX3. Its general reaction benzene ring, halogen forms halobenzene. Now going towards specific example, we are going to perform chlorination of benzene ring. Then what happened? Its mechanism is, in first reaction, that chlorine will react with iron chloride. FeCl3 will react with Cl2, and during this reaction there will be the formation of chlorine positive and FeCl4 negative. Cl positive is actually electrophile, electron loving species, and in second step this Cl positive will attract a pi electron of benzene ring towards itself. In second step, this positive chlorine ion will attract these two electrons and forms ion, and in third step there is the formation of benzene ring by the removal of hydrogen atom from this carbon, and this hydrogen will be removed by Cl negative, that's formed in first step, generation of electrophile. This Cl negative will pick this hydrogen atom, and these electrons will come into again benzene ring. It forms HCl and benzene ring. Here is the product that's known as chlorobenzene. Compare this reaction with general mechanism. We can clearly see that this reaction follows these three major steps that are involved in reaction mechanism. Now going toward the next reaction, that's alkylation. Alkylation. What is alkylation? It is the addition of alkyl group. It is the addition of alkyl group. It is also known as Federal-Kraft alkylation. Introduction. These are actually substitution reaction, so we cannot use the term addition. It is the introduction of alkyl group, introduction of R group in benzene ring. In this case, we use catalyst AlX3. AlX3 is catalyst. Or we can say that during Federal-Kraft alkylation or acylation we use Lewis acid, and reactant is alkyl halide. Alkyl halide. General reaction. During general reaction, we can mention one hydrogen is replaced with alkyl group, forming hydrogen halide. In mechanism, now we can see that how it is replaced by alkyl group. Now going toward the mechanism. First step was the formation of electrophile, and in this case first step is the formation of electrophile, in which one alkyl halide and its alkyl chloride will react with AlCl3, aluminium trichloride. The chlorine present in alkyl halide will attack on this aluminium and forming R positive, that's electrophile, electron loving species, and AlCl4 negative. In second step, a pi electron of benzene ring will attack on that electrophile, electron loving species. Its electrophile. These electrons will attack on this alkyl group and forms this product. Here is alkyl group and here is the positive charge. Now in third step, there is a removal of a hydrogen from ion here is R and hydrogen positive charge. This Cl negative will pick this hydrogen atom. Chloride will pick this hydrogen atom, forming hydrogen chloride, and there is the regeneration of benzene ring. You can form toluene, you can form ethyl benzene, you can form any side chain benzene. It is again, we can see that it follows the three major steps that were firstly explained, general reaction mechanism, and now going toward the third reaction, that's acylation. Acylation. It is also known as Federal-Croft acylation. And what is acylation? It is the introduction of acyl group. Introduction of acyl group. What is acyl group? It is a carbonyl group. It is actually carbonyl group having one alkyl group and known as acyl group. In general reaction, benzene ring is added in the mixture with acyl halide or halogen or acid halide, and it forms acyl benzene with the removal of hydrogen halide. Now going toward its mechanism, again it will follow those three steps that were explained in general mechanism. Now first step is the formation of electrophile. In this case, AlCl3 reacts with halogen acid these electron attacks on aluminium and forms electrophile AlCl4 negative and C carbon double bond oxygen R. Now this carbon having positive charge is electrophile electron loving species. In second step, benzene ring is ready to react on this electrophile. These electron reacts on this positively charged carbon atom and form such product carbon double bond oxygen, and here is alkyl group. And again I am mentioning positive charge on the ring. Now in third step there will be the removal of hydrogen atom to form again aromatic character, again benzene ring in third step, and that hydrogen ion will be removed by this anion, that's chloride. Benzene ring, carbon double bond oxygen R group, and here is hydrogen atom positive charge. Cl negative will pick this hydrogen atom and forms benzene ring. and it is formed acyl benzene and HCl. Now moving toward third reaction, that's nitration. In case of nitration, there is the introduction of NO2 group. I think it's fourth one. First one was halogenation, second was alkylation, and this is acylation. Now fourth one is nitration. It is the introduction of NO2 group in benzene ring, and it is done in the presence of nitric acid HNO3 and sulfuric acid H2SO4. In general reaction, it forms nitrobenzene. HNO3 reacts with benzene ring to form nitrobenzene, forming a water molecule. Now its mechanism. In mechanism, first step is the formation of electrophile. In this case, this nitric acid and sulfuric acid reacts to each other. HNO3 reacts with sulfuric acid and forms NO2 positive water molecule and HSO4 negative. In next step, NO2 positive is actually electrophile, electron loving species, and in next step benzene ring will attack on NO2 positive. Benzene ring, in second step benzene ring will attack on NO2 positive and forms this product. Here is the positive charge, and in third step there is the removal of proton from benzene ring here is hydrogen atom and here is the positive charge. This anion HSO4 negative will pick this hydrogen atom and again forms benzene ring. Forming nitrobenzene. In last reaction, there is the sulfonation of benzene ring. It is the introduction of HSO3 in ring. In this we use sulfuric acid for sulfonation. we use sulfuric acid for sulfonation of benzene ring. In first of all, general reaction of sulfonation. What is the general reaction of sulfonation? Sulfuric acid reacts with benzene ring and forms sulfonic acid, benzene sulfonic acid. And water molecule. Now mechanism. First step is the formation of electrophile. In this reaction, sulfuric acid reacts with sulfuric acid and forms HSO4 negative, H3O positive and SO3. In this reaction, SO3 is electrophile and it is electrophile having no positive charge. How SO3 is electrophile? Now going to its structure. In SO3, sulfur is present in center and 3 electronegative atoms are surrounding it. Each oxygen attacks electron, bonds electron pair toward itself. These electrons are withdrawn to this oxygen and here, forming partial negative charge, partial negative and partial negative. In that case, sulfur has deficiency of electron and there will be charge partial positive. So it has the ability to attack electron pair of benzene ring. In second step, pi electron will attack on sulfur atom. This pi electron will attack on sulfur atom and these electrons will come to oxygen atom. It forms benzene ring. Here is SO3 negative and here will be the positive charge. In third step, there is the removal of hydrogen ion from ring and that hydrogen will be removed by HSO4 negative. SO3 negative, positive, hydrogen plus HSO4 negative. HSO4 negative will pick this hydrogen atom and form benzene ring. Now still it have negative charge on SO3. In reaction mixture, there is proton H positive and this charge will be neutralized by H positive atom. This negative will pick this hydrogen and form HSO3. HSO3. These are the substitution reactions of benzene, and we came to know that substitution reactions of benzene are actually done in 3 steps. Their mechanism consists on 3 steps. First step is the formation of electrophile, and second step is the attack of benzene pi electron on that electrophile, and the third step is the reformation of benzene ring. We can remember this general mechanism to do other 5 its reactions, substitution reactions. If you have any question regarding substitution reactions, you can ask in comment. Thank you and Allah Hafiz.